Okay, so good morning. Today we are going to solve some problems in chapter 8 in the confidence interval. Okay, so this is problem number 8.3 in chapter 8 of Ken Block. Okay, so let's start. So this problem here, another reminder, if you already watched this video, pause the video and then try to solve the video on your own. Okay, please study the video, not just watch the video. Okay, so let's start. So before we read the problem, we have to draw first the framework of the problem, and then every time we read some values, and then we have to put that values in our framework. Okay, let's start. So a random sample of 81 items is taken, so that is the sample size, producing a sample mean of 47, so that's the sample mean 47. The population standard deviation is 5.89. We put the population standard deviation and then compute a 90% confidence interval. So our alpha here is 0.10. 0.10 because this is 1 minus the 0.9 here. Okay, this in this decimal form, this is 0.9, so 1 minus 0.9, so that is 0.10. That is our level of confidence. Okay, and then what we're trying to predict the population mean using our we call this one as our point estimate. Okay, to predict the population mean. In this particular case, we're going to use this formula here. So this is the first formula, and then just simply substitute the values. Okay, but in this case, we still lack the value of our z here, the z value here. So we have to compute. We have to look at the z table. We have to look at the z table to find the z score at alpha is equal to 0.10. But take note, guys, in confidence interval, we have to divide the value of our alpha here because this is two-tailed. So that is why the 0.10 will be divided into 2, so that is 0.05. And then we have to look the value of the 0.05 here in our z table. So I will attach the z table by the book of Berenson. Okay, so 0.05, you cannot find the exact 0.05 here. You can use interpolation to find the exact value of 0.05, but in some particular case where decimal point is not very strict, we can just simply use this value here. So we can estimate that the value of 0.05 is around negative 1.6, and then negative 1.6 plus the value here of 0.4, so that is negative 1.64. Okay, so if you're going to look at here, negative 1.64, okay, that's approximately the same. Okay, and then after that one, the negative 1.64. We can also use we can also memorize this one in solving the level of confidence for the 90. That is 1.645, 95, 1.96. These are the common level of confidence used in research. Okay, but the most common is the 95%. Okay, the 1.96, the z value of 1.96. Okay, and then you substitute the value of 1.645 here, and then we can compute for the value of this one here, 45.92. So our population mean is greater than 45.92 but less than 48.8. But if you're going to submit this report to some supervisor who was not very good in mathematics, so he will not be able to understand this one, so we have to convert this one to words. So using the sample mean of 47, we can estimate that we are 90% confident that the sample mean and the population mean ranges from 45.92 to 48.08. Alright, so good luck and God bless.